Hello, this is Mrs. Boots, and this is our lesson on solving systems by elimination. Now, we have already learned two other methods for solving systems, right? We've learned how to graph them and find the point of intersection, and then we've learned substitution. So if those two methods weren't working for you, perhaps this one will. So we can use solving systems, we can use the elimination to solve them when we have specific conditions. And those conditions are that I have one variable in each equation where the coefficients are equal but opposite sign. So I'm looking for the same number for the coefficient. That's our first step. We're going to look for the same coefficient with the opposite sign. Okay, same number, opposite sign. Now, if we don't have that, it's not the end of the world. We may be able to multiply, right, to get that condition, that same coefficient with the opposite sign. So we can always multiply to get that same number in the opposite sign. Our third step is going to be to add our equations together. Okay, so let's look at example 1. First thing I'm going to look at is the x's. So I see I have a 3x and a negative 2x. So they're the opposite signs, but not the same number, which means I would have to multiply on both of them. Well, let's check the y's. The y's, I have 4 and 4. So I have the same number, but not the opposite sign. That seems a little easier to me. You can do it either way, okay? You can do the x's or you can do the y's. I'm going to pick the y's. I'm going to multiply this equation, everything, by -1, okay? Just multiply through by -1. So we're going to write the top equation down just like it is. 3x plus 4y equals to 18, all right? And then on our bottom equation, we're going to multiply by -1. Now that's going to change all the signs. So it changes to a positive 2x minus 4y equals -8. Now we can go through and add. This is the beautiful part. So notice when we add those two equations, what happens to the y's? Well, I have positive 4y, negative 4y. They cancel. 3 plus 2 is 5. So I have 5x equals 18 minus 8 is 10. Okay, well, we're close. We're real close. We're on step 4. Now we're going to solve. We're going to solve for that variable. So when I solve for this, what do I have to do here? Yep, we're going to divide by 5. Both sides divide by 5. We divide by 5, we're going to get x equals to 2. Okay? This is only half of the answer, just like it was with graphing, just like it was with substitution. So our last step is we have to plug it back in and find the other variable. Okay, so we're going to plug it back in and find the other variable. All right? So I'm going to I can pick. Where do you plug it into? Well, that's the beauty of it. It can be the top equation or the bottom equation. It doesn't matter, as long as you use the original equations. Don't use the ones that you've multiplied and changed because you may have multiplied them incorrectly. And then you won't get right answers, okay? So let's go ahead and go to the original equation. I'm going to pick the second one just because the numbers are smaller. So I have a -2 and I'm plugging in x plus 4y equals to 8, okay? So we're going to take x and we're plugging it in. So what is -2 times +2? Yeah, it's a -4. So I have -4 plus 4y equals to 8. Okay, so what are we going to do? We're going to add that 4 to the other side. I get 4y equals to 12, right? And then, let me show the adding the 4. We're going to divide both sides by 4. And what is y equal to? Very good. y is equal to 3. So my answer for my problem is 2, 3. Remember to always write your answer as an ordered pair. All right? Both of them. Always include both. Okay? So same steps. Let's look at problem number 2. I have 2 for my x and a -1. Okay. It's opposite signs, but not the same number. Let's check the y's. I have a 1 and a 3. So it doesn't matter which one I pick, I'm going to have to multiply by something. Well, that's okay. Let's just pick the x, and I'm going to multiply the bottom equation by 2. Simple enough. So we're going to write the top equation down. 2x plus y equals 3. No big deal. Now we're going to multiply by that 2 and write the bottom equation down. So I have -2x. 2 times 3 plus 6y. 2 times -12. -24. Okay, so the numbers are a little big. That's okay. We can handle, right? We're going to add them together. Step 3. Add them together. The x's cancel. Isn't that beautiful? So now we have the y's. 1 plus 6 is 7. So I have 7y equals. Now I have +3 minus 24. You got it. -21. Okay, so we're going to divide by 7. Y equals -3. Cool. Okay, so now I can pick. I'm just going to go with the top equation on this one. So I have 2x plus, there's a y, equals to 3. So we're going to take the y we just found and plug it in. -3. Okay? So I have 2x minus 3 equals 3. Let's write it in there without the parentheses so we don't confuse ourselves. Now what do we do to solve for x? Yeah, we're going to add that 3 to the other side. So add 3, add 3. 3 plus 3 is, I know, it's so anticlimactic, it's 6. And then we divide by 2, and we get x is equal to 3. So our answer is 3, because I got to write the x first, comma, -3. That's my y value, okay? So those are the first 2 examples from your notes. We have 3 more examples that we will do in the next video. Make sure that you've got your steps written down and that you have them to reference because we're going to use those steps for example 3 and example 4. Welcome back, and this is Mrs. Boots, and we're still solving systems by elimination. This is part 2. We're going to do examples 3 through 5 so that you can go ahead and get started on the simple solving. Okay, this is review from Algebra 1. This is our 2x2. And then we will have a third video for our 3x3s, which are a little bit more crazy, right? Okay, so super simple. Remember, we look for same coefficient, opposite signs. So I'm looking at my x's in example 3, and I see they both are negative, both -1. That's interesting. We could switch that really quick. Y's, both positive and both a 1. Something's fishy here. Well, we're just going to multiply. You pick. What do you think? Top or bottom? Well, we keep doing the bottom one, so let's do the top one on this one. We're going to multiply everything by -1, okay? So that means I'm going to have a positive x minus y equals to 1. Simple enough, right? I didn't change the bottom equation, so I'm just going to write it down. Not a big deal. Okay? Now we add them together. X's cancel. That's what we wanted to have happen. Uh-oh. Oops. The y's cancel. So I've got a 0, because 0 plus 0, well, that's just equal to 0. So we can put that in there. 0 plus 0, right? And then I have 1 plus 2, which is 3. So does 0 plus 0 equal to 3? Now, Mrs. Boots is not crazy, and neither are you. Well, I might be a little crazy, right? Okay, so this is a false statement. Wait a minute. We saw this before. Where did we see this? Yeah, in substitution, we got a false statement. What does that mean? That means there is no solution, right? So what does that look like on the graph? Yeah, you got it. These are parallel lines. They're not going to touch. They're never going to cross. So I don't have a point of intersection. That's okay. Unfortunately, there are problems in life where we have no solution. They're not always fun, but they are there, okay? So let's look at our next example. That one's done. Example 4. What are we going to do here? X's. I have 2x and I have a 6x. Both positive. Okay. Y's. I have a -1 and a -3. Well, the y's are smaller numbers, right? So how do I turn a 1 into a 3? Yeah, we're just going to multiply by 3. I'm going to do top equation again, but I have to change the sign, right? Yeah, the signs have to be opposite. So let's multiply by -3, okay? So distribute to all of it. -3 times 2 is, very good, -6x. -3 times y plus 3y equals -3. And you're scratching your head. You already see it, don't you? Yeah, you guys are smart. You're all smart. So we got 6x minus 3y equals 3. That was our second equation that we didn't change. We're going to add them together, and you already know, not only do the y's cancel, but my x's cancel. But here's the cool part. -3 plus 3 is 0. Okay, so does 0 plus 0 equal 0? I hope so. Yes, it does. This is a true statement. Okay, and since it's a true statement, what does that mean? Well, it's not a no solution, and that's what usually happens is I get students who get to this point, they're like, I got 0 equals 0, no solution, I'm done. Wrong. This means all real numbers. It's a true statement. That means I can plug anything into those equations and I will get a solution, all real numbers. All right? So if I put it on the graph, what have I got on the graph? Yeah, I've got the same lines. Super easy. So it is possible in elimination to get a no solution or an all real numbers. Now we're going to do a simple example. That's a word problem. I know you guys love word problems. Remember, when you get a word problem, don't read it the first time. I know the English teachers are cringing. The first thing I always do is go through and circle my numbers, right? So in example 5, I see 21, circle it. I see $3, circle it. And that's it. So I know I got to do something with 21 and with 3. Now I'm going to go back and read. Yeah, you do have to read it, okay? But what I'm doing is I'm reading with a purpose. I want to know what that 21 means and what does $3 mean. What am I going to do with those numbers, okay? So let's figure it out. John has 21 coins. That's a total. So I have something equals 21. All right, that's what that just told me. All dimes and quarters, okay? So that means if I add up the number of dimes and the number of quarters, I'm going to get 21. Just count the coins. 21, okay. Now he tells me that it's all worth $3. So that's another total. Now, notice I didn't put my decimal in there, and I'll tell you why in a second. Most people don't like working with the decimals, and this makes the problem a little easier. $3 is also what? 300 pennies. That's okay, right? So how many pennies makes a dime? 10. Okay, and how many pennies makes a quarter? 25. Okay, now I could have put 0.10 and 0.25 and 3.00, and that's fine. We can do it that way, all right? And then you just got to deal with the decimals. Most people don't like dealing with the decimals, and that's why I do it this way, okay? Now we're doing elimination, right? So we're going to look at our coefficients. So coefficient for D, I have 1 and I have 10. They're both positive, okay? I have 1, I have 25. They're both positive. Which one's the smaller number? 10, right? So let's use the 10, okay? It's a smaller number. So I'm going to multiply everything in this equation by negative 10. Remember, it's got to be the opposite sign. So I have negative 10D minus 10Q equals negative 210. And multiplying by 10 is easy, right? You just tack zeros on the end. That's another good reason to pick it, okay? So now let's add them together. We're on step 3, right? We got to add it together, okay? Dimes cancels. Now we're doing with quarters. 25 minus 10 is 15. And then 300 minus 210 is 90. That looks easy enough. I just got to divide by 15, right? Divide by 15, divide by 15. Okay? What's 90 divided by 15? 6. Okay? So I have 6 quarters. Okay, so remember with word problems, you don't just put an ordered pair. With word problems, our answers mean something. So we have 6 quarters. We're going to label it. Okay, now I'm going to figure out how many dimes. So I'm going to go back to my top equation. So I have dimes plus 6 equals to 21, right? We subtract that 6 over the other side, and we get 15. So we have 15 dimes. That is my solution. I have 15 dimes and 6 quarters. And this concludes all of our simple 2x2 solving systems. Now in the next video, we're going to get a little crazier, okay? We're going to do the Algebra 2 stuff. We're going to do 3x3s, okay? So just hang in there and we will fly.